Hi everyone, my name is Roy and I'm a team member at AnyLog. In this demo, I will show you how to deploy a test network with 4 AnyLog nodes. First, I will deploy a master node that maintains the shared metadata. I will then deploy a query node that will be used to query data from the network. And then I will deploy 2 operator nodes that will host the data. The operator nodes will be configured such that each node maintains a subset of the data, and I will show how queries are satisfied as the distributed data is centralized. I will also deploy a remote CLI. The remote CLI is an AnyLog web GUI that provides a simple way using REST to interact with the AnyLog nodes and query data. I'm following the document called Fast Deployment of the Test Network, which you can find in the AnyLog GitHub repository. In this deployment, I will use 2 physical machines. The top terminal is machine A, which will host the master query in 1 operator node. The bottom terminal is machine B, which will host the second operator node. To get started, I will first clone the AnyLog GitHub repository and register our Docker credentials. We can do so using the following command. We can then register our Docker credentials using this command. And we'll copy this credential across both terminals. Now that we have a Docker installed, we have a dist setup with a training directory and a subdirectory for each type of node. To install the master, I will cd to the AnyLog master directory. In this directory, we will find 2 files. The Docker compose file, which will direct the download process, and the AnyLog config file, which is the configuration file for the master node. This file determines the services that will be offered by the node. Inside the configuration file, in this config file, I will update the AnyLog license key if not provided. As this is the master node, the node type needs to show master. We also specify the node name, which is AnyLog master, and we also specify the company name. And for demonstration purposes, let's replace this for AnyLog. I will also keep the ports as default, and we will also specify the ledger connection, which represents the IP and port of the master node. Since this is the master node, it is set to 127.0.0.1, which is localhost, and the port is 32048, which is the default master node port, as specified here. I will keep monitor nodes as true. This flag enables the rule engine of the node to deliver periodic status information. Once the remote CLI is deployed, I will demo how status information from the network nodes is collected and monitored through a single point. Now that we have completed the configuration file, let's deploy the master using the docker compose up-d command. When a node is deployed, it offers a command line interface. This command line allows you to monitor the node status, configure the node, and run queries. From the CLI of each node, users can configure and monitor not only their current node, but every node in the network. In this training, I will issue the test network command on the CLI of each node we deploy to determine that the node is registered in the network and can communicate with peer members. Now that the AnyLog master node is deployed, we can connect to it using the docker attach command. Note that we need to hit enter once to activate the command prompt. When the node is brought up, it prints status info, which depends on the configuration. The master in this training is configured to present the list of services that are enabled by the configuration. Now that I can always issue the get processes command on the CLI to view the enabled services. So let's do that. Let's issue the test network command now. This command lists the members of the network as well as a plus sign to indicate if the node is reachable through the IP and port the node published on the shared metadata layer. Currently, we only have the master node in the network. Therefore, the command returns a list that only includes the master node. The plus sign indicates that the IP and port are reachable. I will copy the master IP and port to the notepad. The reason is that this IP and port serves as an ID of this network. So let's bring out a notepad. Let's copy the IP and ports. For a node to join the network, it needs to communicate with the master node, and therefore we will add the master IP and port to the configuration of each node that will join this training network. Another frequently used command that shows the IPs and ports used on each node is the get connections command. So if you run this command, we can see that the IP and port for the TCP connection on the master node is this, and we can see that we can connect to this node via REST using this IP and port. The IP and port used to communicate with peer nodes are marked as TCP. The IP and port that the node is using to communicate with third-party applications is marked as REST. I'll hit Control D to exit the master node CLI while keeping it running. Now to deploy the query node, we can just go back one directory and cd into the AnyLog query directory. In this directory, we have our Docker Compose file again, and also a configuration file. In this configuration file, we specify the AnyLog license key. We specify that the node type is query. We specify that the node name is AnyLog query. Note that this node name must be unique across all AnyLog query nodes deployed in the cluster. We also will take the default ports and we will update the company name to AnyLog for consistency. We also mark that the ledger connection, which again is the connection to the master node, is 127.0.0.1 on the port 32048. Note that since we're deploying the query node on the same machine as the master node, we connect via localhost. However, if we were to connect on a different machine to a master node, then we would need to connect using the IP that we jotted down here below. We also will enable monitoring nodes to be true. To deploy this node, we can run our docker compose up-d command. And we can see that the AnyLog query node has been deployed. We can attach to it using the docker attach command. Again, we press enter. And now that we're connected to the AnyLog query node, we can issue the test network command. We can now see that we deployed an AnyLog master node, and the status symbol is plus, which is good. And we also deployed a query node, where the status symbol is a plus. Again, that means the query is connected to the master node. So we can now exit this node by hitting Control D, and we can start the process to deploy a operator node. To deploy the first operator node, we first need to update the configuration file. And to do that, we enter into this configuration file. We need to specify the license key. We specify that the node type is operator. We need to specify a different node name since we're deploying two nodes. Here, we'll specify that the first node name is operator 1. And when we deploy an operator node on our machine B, we'll specify that it is AnyLog operator 2. We'll update the company name to AnyLog. We'll keep the default ports, and we'll also specify that the master node can be connected to via localhost on port 32048. We also need to specify a unique cluster name. This we can do by labeling this as AnyLog cluster 1, and we can specify that the default DBMS is AnyLog. We will enable MQTT. With this flag, when the machine is up, it will receive telemetry data by subscribing to a third-party broker. How to stream data to a node is discussed in a different demo. However, when we bring two operator nodes up, we will have two operator nodes receiving data, and I will show how we can query the distributed data from the two nodes as a single and unified collection of data. The data will be stored in our default DBMS, AnyLog, which we specified above. Note that users can add logical databases as needed. This is only a default name that will be used if no database is associated explicitly to the data entered. Now that we've configured our AnyLog operator, we can deploy it using the docker compose up-d command. And now that our AnyLog operator node is up and running, We can attach to it using the docker attach command. If we run the test network command, we will see 3 nodes in the network, a master, query, and 1 operator. We can see that all these nodes are successfully running given the status is a plus. Since this node is configured with a service subscribing data from a third-party broker, I can monitor the streaming of data to the node using the getStreaming command. With this monitoring command, a user can see the list of logical tables that are updated with data and information on the data that is streamed to the node. Note that when many nodes are deployed, it is possible to monitor all the nodes through a single point. I will later deploy the remote CLI and show an example of monitoring multiple nodes through a single point. To deploy a second operator, I will switch to the second terminal. I'm now deploying a node on a different physical machine, and I will follow the exact same steps which I did to deploy the first operator. To do so, let's cd to the AnyLog operator directory. And let's update the configuration file. Again, we have the AnyLog license key. We specify that the node type is operator, and here's where we need to ensure that we're specifying a unique operator name. So we'll name it AnyLog operator 2. We'll specify the company name is AnyLog. We'll leave the ports default, and here we need to update the IP to the master node IP, which we jotted down below. We also need to update the cluster name. So we'll do this by specifying it as AnyLog cluster 2. We'll update the default DBMS as AnyLog, as before. We'll enable MQTT to be true, and we'll also monitor these nodes. And now that we configured our operator 2, we can deploy it using the docker compose up-d command. Now that our AnyLog operator node is up and running, we can attach to it to make sure that it is connected to the entire cluster. To do so, we can run the test network command. And we can see that we have 4 nodes deployed. We have our AnyLog master node, we have our AnyLog query node, we have our first operator node, and our second operator node as well, all with the status plus symbol, meaning that they're successfully connected to the master node. Like with operator 1, we can monitor on this CLI data stream to the node using the getStreaming command. I will not show it now, but I can on the CLI monitor the data from the 2 operators as if the 2 physical nodes are a single machine. Let's now show examples of queries using the query node. To do so, we can exit out of the operator node, and we can attach to the query node. For example, I can issue the same queries from an operator node. When an application connects to the node, it can ask the node for the virtual tables. If I run get virtual tables, we will get the reply that an application gets when it receives the first list of tables. In this training, I did not create the tables. The tables were automatically created by the streaming data that each operator received from the subscribed brokers. These are the tables laid out 1, 2, 3, and 4, and they are all assigned to the default DBMS of AnyLog. In the same way that I can query a centralized database for the columns in a table, to do that, I will use the getColumns command to retrieve the column names of a virtual table. We can show this down here. As we can see, these are the columns for table layout 1 on DBMS AnyLog. Now, using the column names, I can issue a query to the data in the virtual table without knowing which are the operator nodes that host the data. In this training, we show the data of each table is split between operator 1 and 2 of our network. If I'm an administrator that wants to monitor how the data is physically distributed at the edge, there are many ways to do that. I will use the getDataNodes command, It shows for each table which are edge nodes that host the table's data, and as you can see in this example, each table's data is partitioned into 2 nodes. So let's run this command. As you can see, for each table, Lighthouse 1, 2, 3, and 4, there are 2 nodes that host data for that table. We can also see the IPs of the nodes. We can see that one node is running on IP 178 and the other one is on 198. These are 2 physical machines, and both of these represent operator 1 and operator 2. Let's now issue a query to select the number of rows in Lightout 1. The command starts with the keywords run client, as shown here. The run client keywords mean that we can run against the network nodes as a client to the network. I'm keeping the parentheses empty because I want the network protocol to identify the target nodes. The other option is to specify in the parentheses the target nodes. There are different ways to do that, but I will not detail this in this demo. Then I will have the keyword SQL. This keyword means a SQL query followed by the DBMS name, which is AnyLog. Then there are different options that can be added. I use the format table to format the output as a table, followed by the query. The query returns the number of rows in the 2 nodes as if they are a single machine. You can see in the statistics that there are 2 nodes that were considered. And so we can do that by running this command. And we need to replace our DBMS name. And we can see that we have 2 nodes and that there are 13 rows in Lightout 1. The second query receives the rows in the table and is issued in the same manner. This time we are asking for 20 rows. Let's replace the DBMS name with AnyLog. And we can see that we received 13 rows across 2 nodes. Note that if AnyLog returns an error message to a command or a query, I can issue the getErrorLog command to view the reason for the error. We can see when I copied this second query, it automatically hit return without specifying the DBMS name. We can see that this was an error picked up by AnyLog. The Remote CLI is a web-based application that sends commands and queries to AnyLog instances using REST. In this demo, I will use the Remote CLI to issue queries and commands to the query node. Let's exit the query node now and cd to the Remote CLI directory. Again, we can hit Control-D and we go back one directory and cd into the Remote CLI directory. To deploy Remote CLI, we just need to enter docker compose up-d. I can connect to the Remote CLI from any browser using the IP of the node that hosts the browser and port 31800. Since we're running on this machine, we can connect to it using 31800. Now that we connected to the AnyLog Remote CLI, we need to specify our connect info. The node that we want to connect to is the query node, which is located on IP 178.79.143.174. And the port is 32349. And we specify that in our connect info. If I'm not sure what the query node connection information is, I can attach to the query node and I can run the get connections command. We can see that this is the IP and port that we want to connect to. Like the local CLI on each node, I can use the command line of this web GUI to monitor, configure, and query a target node, or groups of nodes. For now, let's issue the getStatus command to the query node to validate that the query node is running and is reachable from this GUI. To do that, we can run the getStatus command. Let's now run the first query to count the rows in Lightout 1. To do so, we can take the query from here, put it in the command. We remove the run client. Note that rather than specifying the run client keywords, I'm checking the network box instead. This has the same meaning as run client on the node CLI and will execute the query against all the nodes that host data of table Lightout 1. So now let's run this query. Let's also specify the DBMS to AnyLog. And let's run this query. As we can see, the count increased as data is constantly coming in to the operator nodes. And now we can do this with the second query. Again, we can remove the run client keywords as that is the same thing as pressing the network button here. And we just specify the DBMS name as AnyLog. And we hit send. Again, we can see that we received 20 rows from 2 nodes. The AnyLog setup allows us not only to query and monitor the distributed data from a single point, but also to query and monitor the distributed resources from a single point, very much like a centralized cloud that monitors CPU, network, and disk usage of the cloud resources. Here is a page that is using AnyLog to monitor CPU, network, and disk usage of the distributed edge resources. To get there, we hit the monitor button, and we issue our connect info as 178. This is our query node, and we press pull. And now we get all the information about our 4 nodes. Before I end this presentation, I want to highlight that in this demo, we are showing first a deployment of a test network that unifies and organizes the data on multiple edge nodes. We show how to query the data and monitor the resources from a single point as if the edge is a cloud environment. And finally, we do this by deploying AnyLog without a single line of code. Thank you for watching this demo, and I'll see you on the next one.